Hello guys. So let's understand what is blockchain, Ethereum, and smart contracts with the practical analogy. So what is blockchain? So blockchain is a decentralized ledger stored on a peer-to-peer network. So this decentralized ledger can also be considered or can also be seen as a data structure. So a data structure is a simple arrangement of data which stores some information in some structured format. So a real life example of the data structure of, or you can say the blockchain would be records of your sales and purchase for your shop or for your business, or maybe simply a bank account statement, which can also be seen as a ledger. It can be a simple Excel sheet tracking all the hospital equipments, sales and purchase and consumption. It can also be seen as a simple and the large size book, or you can call it a PDF. So we can refer the blocks in the chain, right, as a with the pages. So one page can be considered and seen as a one block, while the series of the pages, which is called a book, can be seen as a blockchain. So so let's jump into a simple analogy and relate everything with it. So imagine it as an old time book based on a ledger. So you know that there, when in the few years back or in the last few decades, the all the ledger in the bank when the computer was not there, used to be based on the simple hard book copy. So it was a hard copy. It was a book where the all the entries and the balance used to be mentioned over there in form of the ledger. So where the each page reference to some previous pages through the page number. So tearing up a page from a book or from the ledger might be a simple signal that somebody has tempered the block or somebody has tempered the ledger. So here the book is equal to blockchain, the page is equal to block, and the entry in the page is nothing but a blockchain transaction. So whenever somebody says blockchain, you should see the blockchain as a book which has a multiple entries in it. So it's very simple that it is very easy to detect if the page or the block has been removed or deleted because of the page numbers. And also it was easy to arrange the pages and identify any suspicious activity in case of any tampering. So that's why the page number were important in the ledger. And still now the page numbers are important in the legal agreements because it is important that we should keep the track of each and every page. So in the blockchain, since the pages or the blocks are built tightly on top of each other, it is impossible to tamper the previous entry in the ledger without someone noticing it. Since each and every block has been linked to each other through the signature of the previous block, it is impossible that somebody changes it and you will not notice it because all the upcoming blocks will be invalidated. So this is how it works, and this is how the entire blockchain will looks like. So first block is also called a genesis block. Is it actually keeps the basic number and signature inside this block is generally zero, and then it has all the ledger entries. So it can be a pre-mined balance or the balance, the default balance, or you can call it an initial balance, and some transactions which have been just created. So let's say A transferred B 1 coin, B transferred E 3 coins, and E transferred D 6 coins. So these entries are called transactions, and these are the balance, right? And then this block also has a nonce, which is just a random number, and then signature of the previous block. Since it is a zeroth block or the first block, the sign n minus 1 would be 0. Then the whole block content will be converted into the signature of this block and called SHA-256. So this is just an example here, but this signing the block can be different based on the algorithms. So now these sign or the signature of the Genesis block will be embedded into the new block, and then same way all the transaction will be applied on the balance and the balance will be updated, and then the new transaction will be appended, and again the whole content will be crunched into a single small string which is called the signature of the block 1. So now the signature of the block 1 will be created using the content of the block 1, which also includes the signature of the previous block. So again, this signature of the block 1 will be again embedded back to the next block when it will be created. Here, the nonce is just a random number which is being created by someone who is adding a new block. So remember, the person who is adding a new block is called miner, whose responsibility is to verify the validity of the transaction, and if they are valid, add it into the block, sign it using the nonce and their own private key, and then create the signature and publish it. This signature of block 1 should be in such a way that it is lesser than or the higher than the previous block. Whether it is lesser than or higher than, it all depends on the algorithm type. So algorithms can choose it in ascending order or in descending order, but it has to be in a particular format or order. So this way, the responsibility of the miner, the person who is actually adding the block, or the server who is adding the block, will be to guess a nonce in such a way that the signature of this block is lesser than the previous one if we are following the descending order. Then guessing these nonce will require a lot of guesses and lot of sharp or digest calculations before it finalizes the right nonce. So the number of average hashes required to finalize or to guess the one block is called difficulty. So here, as you can see, if a blockchain is built in such a way, in this way, and if you want to temper, let's say transaction 1 of block 1, where E is transferring B one coin, if you want to put it 0 or something else, then changing a single bit over here will change the signature of this block, which is automatically embedded in the next block. It means if you changes this, the new block will not be linked automatically, and the whole upcoming blockchain will be invalidated. So that's how the small tempering of the records can be captured very easily without any computational algorithms or power. So that's the beauty of blockchain, and that's how the immutability has been achieved, because it is very difficult to change it and very easy to detect the changes. That's called immutability in blockchain. So as I said, in case of the real blockchain, each block is built on top of the recent block and uses previous block's signature plus some nonce. So building the block and adding it to the blockchain is the task of the miner. In the public blockchain, it is made computationally difficult to add a new block to prevent the attacks. The reason why it happens, because if a hacker changes a past block and he wants to regenerate the all upcoming blocks, then it should be computationally difficult for that hacker to regenerate the entire blockchain, so that he can actually take a lot of time before he actually replicate it, or he better have tons of money in his pocket to invest in replicating the upcoming blocks. So this automatically make the entire blockchain secure. So here the responsibility of the miner, the entity which is adding the new block, is to try and guess a number nonce in such a way that it gets the crunched with the most recent block's fingerprint. Then it will generate the new fingerprint which will be lesser than the most recent. So it should be in a descending order. So it takes time and computational power to add a block in the blockchain. Hence, there is always a reward. So as per now, as of today, this is 12.5 BTC, and in Ethereum it is 5 Ether. A private blockchain can choose other methods to add a block, as they can trust the miner using the different methods. It can be using the legal liabilities, some contract, some contractual agreement, or something like that. So let's build our own definition of the blockchain. So it's a decentralized database or ledger which store information in form of transactions. It can be public or private. It stores in data in an immutable format. It is highly secure due to decentralization, since everybody has the copy of the entire ledger. It is very difficult to tamper the ledger. And data gets recorded via consensus based algorithms, where the multiple parties agrees whether this particular the records are right or not. It uses cryptography for signing the transactions, and it always exists or it generally exists on the peer-to-peer network, though there can be a single node which is running the blockchain itself. So, blockchain is a consensus based, secure, decentralized public private database which store information immutably over peer to peer network. So, here's the summary. So, I have already figured out that you might have understood all the parts. So, it removes the dependency on the trusted third party for recording the data in the blocks, because the entire P2P network is actually competing with each other to add a new block. So it is automatically considered as multiple people working on a certain task. So you don't have to rely on a third party to do certain tasks for you. So public blockchain are more considered more safe and secure because they use the complex algorithms to avoid the malicious activities. So as I already said, that immutability means very difficult to fake or alter a block and very easy to detect the alteration. And remember, this all exists in the memory and the computers and run as a process. So since that is a blockchain that theoretically we understood, so what is Ethereum exactly? So Ethereum is an open source blockchain based distributed computing application platform which lets you execute the smart contracts on the blockchain without any dependency or any third party. So it lets you automate the particular execution of the transactions using the programming methods on the blockchain, which is initiated by Vitalik Buterin in 2013, and the Ethereum's live blockchain was actually live in 30th July 2015. So the program which runs on the Ethereum computing platform is called a smart contract. So it's a term used to describe the computer program code that is capable of facilitating, executing, and enforcing the negotiation and performance of an agreement. So it can be in form of the transaction. So anything can be seen as a transaction. So smart contract can allow you to put condition loops and whatever you want, if else condition, do while, for loop on the transactions. So any transaction you can actually compute and execute based on certain conditions. So that's how you can actually implement a lot of business logic on the blockchain platform. So entire process is automated and can act as a complement and substitute of the legal contract, because the transactions are being enforced using peer-to-peer network through consensus. So it is very difficult for a smart contract to be damaged, affected, or suspended once it has been deployed. Okay, so that's all about the blockchain and the Ethereum and smart contract.